Unit 2, Section 3. So we're asked to construct a truth value for not P implies not Q, also known as if not P, then not Q. So we have two statements, P and Q. So we write in all the possible truth values, true, 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 false, false, true, false, false. Then we're going to write in our statement to evaluate not P, if the if-then statement, and the not Q. And then we'll begin with putting in the value of not P and the value of not Q. So false, false, true, true, the opposite of P. The opposite of Q, false, true, false, true. So next we just have the one operation, and we remember how the if-then statement works. We know P implies Q is false only if true implies false. So all we have to look for is true implies false and mark that false, and everything else will be true. So false implies false is true, false implies true is true, true implies false, that one will be false, true implies true is true. So you just look for the true implies false to mark it as false. And that is our answer. Example 2, construct a truth table for the given statement. In parentheses, we have not P or Q, and then we have the if then and are. So we're going to need 3. We're going to need P, Q, and are. So we have true, 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 false, true, false, true, and true, false, false. And we'll put our dotted line here to keep things organized. Let's extend these a little. So we have false, true, true, false, true, false, 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 true, and false, false, false. And then our statement, not P or Q, leaving some room, and our if then and are. So we'll begin with our simple statements, our negations, and our statements. So not P will be false, 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 true, 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 true. Our Q is true, true, false, false, true, true, false, false. And our R, true, false, true, false, true, false, true, false. So now we have two operations. We have the or inside the parentheses and the if then outside the parentheses. We start inside the parentheses with or, and let's remember or is true if either is true. Also known as it's only false when they're both false. So we have true, true, false, false, true, 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 true. As long as we have one true, then we have a true statement. Now the if-then. Let's remember with if-then, it's only false if we have true implies false. So we're looking for a true from this column to imply a false in this column. let's see. We have true implies true, true. Here we go. True implies false will be false. False implies true is true. False implies false is true. True implies true, true. True implies false is false. True implies true is true. True implies false is false. So our final answer column, true, false, true, true. True, false, true, false. Example 3, construct a truth table for the biconditional, parentheses, P implies Q, if and only if, parentheses, Q and not R. So we got a long one here with 3 statements. So we're going to start with P and Q and R. And now we're going to have if P then Q, just giving it a little extra room. If and only if, Q and not R. Let's start with our statements. True, true, true. True, true, false. True, false, true. True, false, false. And my dotted line to help things line up. Now, false, true, true. False, true, false. False, false, true. And false, false, false. Okay, there's our basic setup. In our first step are all the simple statements, the statements and the negations. So P, we're going to just copy down as true, 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 true. False, 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 false. Q will be true, true, false, false, true, true, false, false. Q again, true, true, false, false, true, true, false, false. And we have negation R, so false, true, false, true, false, true, false, true. Whoa. Okay, so what do we got? We have an if-then inside of parentheses, the if and only if outside, and the and inside the parentheses. So we need to do both of the parentheses first. So I'll just start on the left. So if then, and we remember if then is only false when true implies false. So true implies true is true, true implies true is true, true implies false is false, true implies false is false, and all of these will be true because they're all starting with false. Okay, so that's what we're going to use in a later step. So I'm going to put a little arrow there so we can find it. Now here we have to do an and our and is only true if both true. So true and false will be false. True and true is true. False and false is false. False and true is false. True and false is false. True and true is true. False and false is false. False and true is false. We're going to use this part. So now with the if and only if, we are comparing the results of the first parentheses with the results of the second parentheses. Let's remember how if and only if works. The biconditional, that we must be the same to be true. So looking at true here, false here, it will be false because they're not the same. True, true will be true. False, false will be true because they're the same. False, false will be true because they're the same. True, false is false. True, true is true. True, false will be false. True, false will be false because they're different. And this is our final answer column. So our answer column for the statement will be false, true, 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 false, true, false, false. So in example 4, we're asked to determine if the statement is an implication, a self-contradiction, or neither. So going back to my sheet, I'm looking for the definition of an implication, and an implication is a conditional statement that is always true. It has to be an if-then statement, a conditional statement, and it has to always be true. A self-contradiction is any compound statement that is always false, or neither. Okay, so we're looking to see, is this always true, always false, or neither of those? Sometimes true, sometimes false. So we have P and Q implies P or Q, or we might say if P and Q, then P or Q. So let's make a truth table. P, Q. So we just have true, 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 false. It's a pretty simple truth table. False, true, false, false. And now we have our statement. P and Q implies P or Q. So very quickly, I'm going to bring down P and Q in each of these. You might be able to skip this step and just look over here at these because there's no negations involved, so it's pretty simple, but I'm going to do it. So true, true, false, false, true, false, true, false, true, true, false, false, true, false, true, false. So our and is true if they're both true. So we have true, false, false, false. Okay. Our or is true if one or both is true. So it's only false if they're both false. So we have true, 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 false. So now we're going to compare these two columns using the if-then statement or the implies. And we remember that is only false if true implies false. That's the only time we're going to get a false. So we have true implies true is true. False implies true is true. False implies true is true. False implies false is true. So we get a statement with only true results. Going back up here where I wrote it earlier, that means we have an implication. So the statement is an implication. Great.